Hello everyone, welcome to a Khan Academy tutorial for advanced reflections in geometry. So this is a particularly difficult Khan Academy, but it's a great supplement to what we do in particularly an honors course. But you can do it in any course. Now the tests or quizzes may not be exactly like this, but this is still great to solidify your understanding of how reflections work. So here we have a problem and it says draw the line of reflection that will map the triangle BFG onto the other triangle below. Okay. First thing we should probably understand is we need to understand how it's labeled. So this is going to be F prime because it's reflected over. Keep in mind this B is going to be that B prime. Okay, this would not be B prime because that would be the same distance away from G. So this is G prime. Make sure you understand that you're reflecting across and you're not translating. So we have F, G, and B prime. Remember that reflections maintain angles and distances between the different shapes. Okay, in this case, it's a triangle. All right. So what we need to do is we need to make sure we can draw this green line right here and show where it belongs in order for it to be a proper reflection. In order to do that, we need to calculate the distance between these 2 points. Remember, a line of reflection goes down in such a way that this distance from the line of reflection and this distance are the same distance apart. Okay, it's the same measurement. So it's very important that we figure out what this distance between these two values are, or if you want, in between these values of B or these values of F. So let's go ahead and let's start with F because it's the smallest distance. So what I like doing is you could use the distance formula, you could use Pythagorean theorem. I'm going to simply use the properties of a triangle. So I know this is 3 units down and this is 3 units across to get there. And this would give me my distance right here. Okay, so that would be my distance between the 2 points. And that would be the hypotenuse of a right triangle. Now, I know that the distance isn't that important. What's important is the line of reflection splits, whoops, I did something wrong, splits that distance in half so that it's equal. So how do I figure out where that midpoint is of that distance? Because the midpoint obviously will split the distance in half. Well, one way to do that is I could figure out what's halfway for the vertical distance and what's halfway for the horizontal distance, and that will tell me what is halfway of my hypotenuse, which is the distance between the 2 points. So halfway down of that, okay, if we look in here where this is in terms of the location, it is, oops, sorry, that's my y-coordinate, isn't it? So my y-coordinate is 4.5 because I go down 1.5 units from 6 to get 4.5. What about my horizontal distance? Looks like my horizontal distance is at 4.5. So 4.5 is the location of that midpoint. Okay, the location of the midpoint is good, but what really is going to help us is understanding the slope. So yes, we need to know where it goes through. Let me move this over. We need to understand where it goes through, but we also need to understand in what way is it angled. Is it like this? Is it like this? Okay, what is the slope of this green line? What else do we know about reflections to help us with this information? We know that it is, number one, a bisector of the distance, so it needs to split that in half, which we just kind of figured out where it needs to go through in order for that to happen. But we also need to figure out the slope. What we know is it is also perpendicular to that line. Okay, things reflect perpendicular. If you're looking at a mirror, it reflects back at you. It doesn't reflect off at an angle or anything like that. So perpendicular reflections. Now, in order to figure out what is perpendicular, we need to calculate the slope of that distance there between the 2 points. What is the slope of that distance on the coordinate plane? Well, we could either use a rise over run, y2 minus y1, or we can just say between F and F prime, it goes down 3, so that's a negative y distance. Change in y over the change in x is a slope. So it goes down 3, and it goes to the right, positive x distance, 3. That also equals negative 1. So if we want a line that is perpendicular to negative 1, what would that be? Well, it would be the opposite reciprocal. What is the opposite reciprocal of negative 3 over 3? The opposite reciprocal is positive 3 over 3, or positive 1. So again, positive 3 over 3 is the negative reciprocal of that. Okay, but we can just write that as 1, which is its simplified form. Okay, so we need to have a slope of 1 that goes through that point. So from this point, we need to go down 1 over 1, down 1 over 1, and it's going to look something like this. Okay, now to verify that's our line, let's just make sure, because I don't really like these decimals, but we might be able to work with it. But we got the general idea of what it looks like, okay? And it looks like it goes through these points here, these intersections. It looks like it even goes to the origin, which is a good thing. That makes it easier for the graph on our Khan Academy. Okay, so then let's do the same process just so we understand it with the b's. So b and b prime. Let's figure out our distance between the two. So we go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Goes down 10, down 10, and it goes to the right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This goes over 10. Now, you'll find that the slope between these 2 points is also the same. It has to be. If it's a proper reflection, the slope of this change needs to be the same, the slope of this change, needs to be the same as this change. So you'll see that it's negative 10 over 10, which is also equal to negative 1, as we showed here. Okay, that's just a reminder that we're doing this correctly. Okay, now if we wanted to find another point where this green line needs to go through, okay, we could find the midpoint where it splits into a perpendicular bisector. Okay, because we want to make sure these two distances are the same, from B to the line of reflection and B prime to line of reflection. So we can find the midpoint of this vertical distance, and the midpoint of this vertical distance, if the whole distance is 10, then the midpoint is going to be 5 down. So 1, 2, 3, 4, 5. 5 is half of 10. We're going to go across, and it's going to go somewhere over here. Looks like negative 1 is going to be our y-coordinate. Now what's our x-coordinate going to be? Well, we're going to go 5 over from this point. 1, 2, 3, 4, 5. Looks like negative 1 is our y-coordinate. So if we use the slope from negative 1, and it's up 1 over 1, we're going to get this green line here. So in your Khan Academy, make sure, I'm going to get rid of some of this stuff. You can pause and rewind this video at any time to make sure you're understanding it. Okay, but if I start at this point, I know these 2 points are definitely on the line. I like this point better because it's at a definite intersection, and I'm going to use the slope, which we determined needs to be perpendicular to the distance slope between the 2 reflection points. And I'm going to go up 1 over 1, up 1 over 1, and it's going to look something like this. So it goes through that point, goes through that point, goes through that point, and you're going to type that into your Khan Academy, and you'll get the right answer. I'm going to go over one more problem quickly, which is down here. It says quadrilateral corn is reflected over the line y equals 4x minus 1, which is drawn below. Draw the image of this reflection using the interactive graph. Okay, so we have CORN. Now, what we need to do is first we need to determine the line of reflection slope, because, which is here. So this is in the form of slope-intercept form. So we got the slope is 4. Now, why do we need to know that? I said because earlier. Why do we need to know? Well, because let's take a look at, I don't know, let's look at O. It's by itself. So O needs to reflect across this perpendicularly. So it's going to be somewhere over here, but we don't know exactly where. How do we find that? Well, we need to figure out the slope of this line so that it makes a right angle, because it's going to be perpendicular and it's going to be the same distance on both sides. That's the property of reflections. It has a 90-degree angle perpendicular and it's equidistant. Okay, so those are some things we need to take into consideration as we're figuring this out. In order to figure out a perpendicular line, we need to know the given slope of the line of reflection, which is 4. In the other problem, we did it in the reverse way. We wanted to find the slope of the line of reflection. This one, we know the line of reflection, and we want to know, as the point reflects, what's its slope. So we need to find something that's perpendicular to 4. So 4 is the same thing as 4 over 1. So a perpendicular line is going to be negative, a slope is going to be negative 1 over 4. Okay? These are perpendicular to each other. So now what I'm going to do is I'm going to start at O, and I'm just going to use my slope to find new points of the line. So I'm going to go down 1, to the right 1, 2, 3, 4. I'm going to make a point. Okay, I'm not to the line of reflection yet. Keep going. 1, 1, 2, 3, 4. Notice how I land on the line of reflection right there. That's perfect. Now I know that I did 2 segments here of going down 1 to the right 4 to get to the line of reflection. Well, if I did that twice, that means I need to do it twice again to get to my point. Okay? Because it needs to maintain distance. So I'm going to go and do this process twice again from that intersection of the line of reflection. 1, 2, 3, 4. Boom. That's once. That's not the same distance. 1, 2, 3, 4. Boom. There I go. So here is my O prime, because it is perpendicular to the line of reflection and it is equidistant. Now I just need to repeat the same process with all these other ones. Now I know what you're thinking. Hey, Mr. West, if I go from R and I go down and to the right, I'm never going to get to the line of reflection. Well, silly goose, what you're supposed to do is you're supposed to go in reverse until you get to the line of reflection. So let's start at R and let's go in reverse. We're going to go up 1, 1, 2, 3, 4 in the other direction. Notice how we still land on the line of reflection. Okay? So we need to do that same distance. We only did one segment of going up 1 to the right 4. So we need to do that just one more time on the other side. Remember, we're reflecting this onto the other side. So here is my R prime. Just do it one vertex, one point at a time, and then connect the dots when you're done. Let's look at C. We go up 1 to the right, or left 1, 2, 3, 4, because we need to head towards the line of reflection, not away from it. So we do it one more time. Up 1, 1, 2, 3, up 1, 1, 2, 3, 4. There is my C prime. And then let's do N. Up 1, 1, 2, 3, 4. Up 1, 1, 2, 3, 4. So I need it twice. Up 1, 1, 2, 3, 4. Up 1, 1, 2, 3, 4. And I get N prime. Now, let's say you want to do it an easier way. Some people find it easier to do just, sorry, I'm having trouble with my line here. Some people find it easier just to reflect one point and then draw the shape mirrored, keeping all the same distances between the points. That works too, okay? I like doing it point by point, but if you're someone that wants to, did I connect these dots right? I don't think I did. No, I didn't. I connected the wrong C. If you're someone that likes to just do one point and then redraw it, sometimes that saves you some hassle. So there you go. That's how you do these particular Khan Academies. I hope this helps. See you next time.